I still had my mic muted because I recorded a video of the animation yesterday. Let me just put this here. Sorry for not having any audio. I was talking to you, but it wasn't there. I recorded this one yesterday. And to do this recording, I actually had to tilt my monitor 90 degrees to be able to do a full recording. So yeah, and to do that I muted the audio because I was having a stream on at the same time, and then I later recorded the voiceover. But I forgot to unmute my mic in OBS. So yeah, everything should be fine now. So yeah, let's start reading Advent of Code Day 12. Hot Springs. You finally reach the hot springs. You can see the steam rising from secluded areas attached to the primary ornate building. And Suncase Software says good morning to you too. Can you hear me just fine? I think it's okay. I see the view meter peak, so I think the audio should be recording for the mic. Let's see. You finally reach the hot springs. You can see the steam rising from secluded areas attached to the primary ornate building. As you turn to enter, the researcher stops you. Wait, I thought you were looking for the hot springs, weren't you? You indicate this definitely looks like hot springs to you. Yes, audio sounds good. Great, thank you for letting me know. Oh, sorry, common mistake. This is actually the onsen. The hot springs are next door, and onsens are actually Japanese bathhouses, so that's funny. You look into the direction the researcher is pointing and suddenly notice the massive metal helixes towering overhead. This way! It only takes you a few more steps to reach the main gate of the massive fenced-off area containing the springs. You go through the gate and into a small administrative building. Hello, what brings you to the hot springs today? Sorry, they're not very hot right now. We're having a lava shortage at the moment. You ask about the missing machine parts for Desert Island. Oh, Olive Gear Island is currently offline. Nothing is being manufactured at the moment, not until we get more lava to heat our forges and our springs. The springs aren't very springy unless they're hot. Say, could you go up and see why the lava stopped flowing? The springs are too cold for normal operation, but we should be able to find one springy enough to launch you up there. Okay, that's a nice little pun. There's just one problem. Many of the springs have fallen into disrepair, so they're not actually sure which springs would even be safe to use. Worse yet, their condition record of which springs are damaged, your puzzle input, are also damaged. You'll need to help them repair the damaged records. In the giant field just outside, the springs are arranged into rows. For each row, the conditional records show every spring and whether it's operational, marked by a period, or damaged, marked by a pound sign or hash. This is the part of the condition record that is itself damaged. For some springs, it's simply unknown, whether the spring is operational or damaged. However, the engineer that produced the condition records also duplicated some of this information in a different format. After the list of springs given for a row, the size of each contiguous group of damaged springs is listed in the order those groups appear in the row. Okay, this is not sinking in yet, I'll just continue reading for now. This list always accounts for every damaged spring, and each number is the entire size of its contiguous groups. That is, groups are always separated by at least one operational spring. 4 hashes will be 4, never 2, 2. Okay, it's not clicking, but let's keep reading. So, condition records with no unknown spring conditions might look like this. Hash period, hash, hash, 1, 1, 3. Okay, this is... So these are no issues here. There are no issues there. So where's the question mark? Okay. So in this case you see 3 markings, but only one of these is actually correct. And the same for this. So this is kind of like a nonogram, actually, but usually you get data in 2 directions that you know how to do it. Okay, let's see. So condition records, yes. However, the condition records are partially damaged. Some of the spring's conditions are actually unknown. For example, blah, okay. Equipped with this information, it's your job to figure out how many different arrangements of operational and broken springs fit the given criteria in each row. Okay. For the first line, there's exactly one way separate groups. There's actually one way separate groups of 1, 1 and 3 broken springs can appear. In that row, the first 3 unknown springs must be broken, then operational, then broken. Ah, okay, I need to... That is part of the text that they had before. I need to revisit that. Making the whole row... let's see, which one was that? Oh yeah, they marked 2 actually. I skipped over it too fast. So yes, this must be on, off, on. So in this case there can be more combinations. We know that this one is on. But these can be either because there is no... these are 2 combos because it can be on, off, off, on. Let me just continue reading. The second line is more interesting. Could be a total of 4 different arrangements. The last question must always be broken to satisfy that the final contiguous groups of at least 3 broken springs. Yes. And each question must hide exactly one of the 2 broken springs. Neither could be both broken springs, or they would form a single contiguous group. Yes, okay. If that were true, let's see, the numbers afterwards would have been 2, 3 instead. Okay. Since each question mark can either be hash dot or dot hash, there are 4 possible arrangements of springs. Okay. The last line is actually consistent with 10 different arrangements. Okay, because the first number is 3. The first and second question mark must both be period. If either were hash, the first number would have to be 4 or higher. Yeah, that is true. However, the remaining run of unknown spring conditions have many different ways they could hold groups of 2 and 1 broken spring. Yes, okay. Bum, 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 bum. Okay. These are all the combinations worked out. So this one will basically be a permutation combination. That will be interesting. Because I have code that allows for this. Yeah, it would be cool if I can use that. I think that will work. I will have to dive into that. It's an interesting problem. The remaining run of unknown spring conditions, because if I make all the permutations, I then have to slice out all the disallowed versions. Let's see. However, the remaining group of unknown spring conditions can have many different... Yes, okay. In this example, the number of possible arrangements for each row is... Okay. Adding all of these possible arrangements together produces a total of 21 arrangements. For each row, count all of the different arrangements and operational broken springs that meet the given criteria. What is the sum of those counts? Okay. So this is a tricky problem, and I'm not sure if I have the correct plan to tackle this yet. So this will be fun. And I assume this will be... Oh, okay, it's not too bad. I expected way worse, to be honest. But yeah, basically this is a kind of constraint solver, and I'm not sure if I've ever written one properly yet. So yeah. I'm just wondering if, like, what I could do is just take this number and the length and then generate each version that could produce and then match it back against this one. Yeah, this is interesting. I don't have a... Usually when I see a problem, it's like, okay, this is what I'm gonna do. Right now, I don't know how I'm gonna solve it yet, so bool test is true. If test. I should probably just add this to the base class because I do this every day now. Input is this, come on. Okay, this is our test input. Okay. So we do input dot two lines. Now 2 lines, and then we select x and split on this, and then we do as this won't be x at 2 now, x at 2 array, x dot split comma as in 32s. Okay. Okay, let's see what it is complaining about, because I think this should be fine. Because we split. Now we get two values. We want the first to be a char array and the second to be a list of numbers. Let's see what it says here. The type argument. Can it be inferred from the usage? Try to specify the type argument. Okay. That is interesting. Does this help? No. Okay. So this one would just be sorry, this is like the output variable. I can do var result with this. Okay, it was just because I didn't assign the result, and this one then has to become, let's do to this, and we should make this a list of char array map, and this will be a int array of occurrences. I wonder why it doesn't like this. So this one jumps into this one, and it's basically just a string. Let me think. Why doesn't it like this? Okay. No, still not. I wonder why it's having issue with this. So this will be char array comma int array. Cannot convert. Let's see. Ah, I'm stupid. This is the problem that I had before. I need to make sure that I do the arrow function here again. So I don't need to write this out like this. It's just, yeah, I forgot to have a second arrow function there, which is my bad. So yeah, we can have, we call this parsed like this. Put it here, have it available for the class. So for each puzzle in parsed. Okay. Let's set up some mappings. Boom, 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 boom. Operational damage and unknown. Okay. Const. Come on. Const char operational. And let me just actually put this here and then zoom the code a bit. Yes. period damaged hash unknown marker with question mark. Okay. So I could actually call these the damage counts. Yeah, this is a really tricky issue. Because something tells me that I should just, for the length of this, try to generate all of these, but it's yeah, it's tricky because the only things that we need to figure out are the question parts. Oh, I'm sorry, that came on so quickly that I couldn't find a mute button. I should put a sneeze button in the Steam Deck and hook it up actually. Sorry for that. Because basically this is like a regex that this one needs to adhere to. So I kind of wonder if I turn this into a regex, if I can just, for the question marks, generate the permutations and then just test which ones match. And that is the closest thing that I can come up with actually. So let's do string generate regex pattern. And this will be int occurrences. So string, let's see. So what we want to do is actually we want at the beginning and start markers. We can have a period as many times as we want, as many periods as we want, and this at the end as well. So here we will have actually string.join occurrences. Because the thing that I want to write out is like hash and then the amount, right? So what I want to do is to have hash like this. And I need to have this in the string format as well. So we have this separated by this, followed by hash this. This will be very unreadable, but I'm sure I'll show you in a bit. It will be fine. So let's just write this out for now and make sure that I can show you what I mean. So we do console.writeLine. Oh, and actually these need to be plus. So this needs to be at least 1 between all of them. Dun, dun. Nearly messed up there. So we have this with this is this pattern. Puzzle dot damage count. Okay. So we have puzzle dot, how did I call it? Map. New string. So for this, actually, I really shouldn't have changed this to a char array because we don't need it. So this can just be string input, boom, like this. Okay. Puzzle the damage counts, and this will be a string join. Okay, so this one, when we run it now, it will just map out our regular expression. So here you can see we have any amount of hashes. Oh yeah, and I need to actually, the thing that we need to match inside are periods actually. Oh yeah, I have that corrected already. So let's see. So we have, so yes, this needs to be period, like this. Let's run it again. Boom, 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 boom. And this needs to be, no, I was wrong. Let's see. Yes, these indicate the amount of broken ones. Okay, this is already tripping me up. So that is fine. So we need to have at least one period between that, and then we have enough. Yes, okay. This will be so much fun. So we have any amount of periods followed by one hash, followed by any amount of periods, which is at least one. So this is 0 or more, this is 1 or more period, followed by one hash, followed by 1 or more period, followed by 3 hash, followed by any amount of periods. So I think if I just regex these all, I can do this. So var r is new regex puzzle dot, let's do string pattern. Pattern is generate. This will be puzzle dot boom 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 damage counts. So here we can just do pattern. This will be pattern. Compiled. Okay. R dot is match puzzle dot input. Okay. True. Okay, so our regexes pass. Now we need to make sure that we alter the ones. And for each question mark, we need to change a. We need to make an alliterative. Generate the options. So let's just do this. I enumerable string generate permutations string input char variance char marker like this. Okay. If so, int marker index is input dot index of marker. If marker index is larger or equal to 0, this means we found one. For each char variant and variance, you do yield return like this, And this one becomes input.substring 0, marker index. Then we take the variant, and then we take the let's see, this one be the input.substring marker index +1. So this one will generate the variants for each of them. So now we probably need one that says generate all permutations, right? So we do var all is generate permutations input marker variance. So this one becomes a change list is this. And we do while change list dot any actually. Let's just do this to list actually. New list. So we do new list is generate permutations. Generate permutations. This one actually we do. Let me see. Because we need to be calling that while it keeps changing. Let me see. Let's do result. Actually, result is this. While var entry and result, var new list is this is a tricky one because we need to be calling it and we need to save the last one because that one will be okay, and if not it will be Can I just actually just here return input yield return input like this? I think I can recursively call it like this, like for each. No, let's do a list result. List string result is new. Let's do it like this. I think this is better. And here we do return result. This becomes a list of results. Let's get away with this. Damn, this is tricky. I wonder why I'm having so much input with this. I wonder why it's complaining here, because I already changed the signature. Not the result. Yes, result. It's a list and these match. So boom, 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 boom. Cannot be an iterative log because list is. I mean, yes, result but add is what I was looking for. But actually, I need to do add range, and then I do generate permutations. So I'm still calling it recursively here, but yeah, marker, comma, variance. So this one will work. Let me see. Let's change the input to the one with the question marks. Like this. Boom. And let's see. So var permutations is generate permutations, and this becomes puzzle.input unknown marker, and this one is I should actually make this a params so that I can just specify it params like this. So that way you don't have to put an explicit array, but you can actually just do a broken damage marker and the operational marker like this. So let's put this here actually. Permutations count. Var valid permutations is permutations select, no, dot count actually, and this is r.isMatch p. Valid like this, valid permutations. Okay, so let's see if we run this. We have 1 4 1 1 4 10. Is this what we want? I think it looks close to what we want. 1 4 1 1 4 10, and woohoo! Code seems to work and do what we want. Regex is for the win for the first time this time. Okay, so let's actually run it against the real input. Is false. Let's also make the conditional printing. So we do test, we do this. And let's see, what is the value that we needed to track? 21 totals, we just counted them. So we do long count, valid options is 0L. Valid options. And we do this plus equals valid permutations. Console, right line. Part 1, blah, valid options. Let's run this. Oh, it doesn't like this. So it generates a lot of permutations probably. Okay, so this is already a pain. So I'm already not as great as I want it to be, but we have the gold star for part 1. Great. Unfolding, Jesus, okay, let's see. As you look out at the field of springs, you feel like there are way more springs than the condition records list. When you examine the record, you discover that they were actually folded up this whole time. Okay. To unfold the record, each row replace the list of spring conditions with 5 copies of itself, separated by a question mark. Okay. Nice work. Thank you. Thank you. Separated by question mark, and replace the list of contiguous groups of damage spring with 5 copies of itself, separated by comma. So, okay. Yes, this is a big pain. And if only we could extrapolate how that would change. Wait, these numbers are relative to each other. No, because this one... Okay. I thought that maybe there was a way to figure that out, but no. So yeah, this one will run a long time, but it will work. My code will work, but I think it will run a very long time. And I actually will just leave this. So yeah, you can see it doing work here. I think if I run it on the new change, it will not be that fast. So let's see. So so I could do puzzle dot input is string dot join question mark, and then we do puzzle new string puzzle dot inputs. Actually, I can just do for int I is 1, I smaller than 5, increment I. So we do puzzle dot input plus equals of this, and then okay. So we do string input is puzzle dot input like this. Puzzle, come on. And I know a string builder would be more efficient, but it's not that bad, and it's a lot more readable here. Int numbers. Okay, I can do it like this. Let's just clone this, and we do the same here. Damage counts is damage counts of concat puzzle damage counts. Okay. Boom. I know this isn't very efficient, but it won't be the issue here. And then the rest will be the same. So yes, let's disable part 1 for now and see what this does to our part 2 code. Not that bad. I thought it would be way worse. Because I don't run it against the actual changed inputs. Okay. Never mind, you saw nothing. So we can remove this one actually, we can remove the pattern. I just want to know the permutations on the count. Yeah, that's what I was afraid of. It won't even print the first one within any reasonable time. So actually, the thing that we need to do, let me think, because it's not just that it introduces more here, right? Because it's the way that the separator between those changes the data. Let me think. So 506050. So why are there 50,000 more introduced here? Is there a way to predict this? Trying to see if there's a different way to go about this. Maybe if I would add the constraint to the permutation code right away so that it doesn't actually generate all of them, that would probably save a bunch, but it would still be very hard. Let me think. Because the issue is that even though there are like, if you do all these question marks, the amount of permutations that you can generate is very huge. The actual valid arrangement that you can generate isn't that big. So if we focus on just this one, we should probably find a way to constraint solve this in a way that you generate the options out of it and not let me see if there's a because I can't figure it out right now. Let me just see C# generate options with constraint set. No, that's not what I need. I'm just thinking, because if I just take this, right? I want to have a list of string generate valid permutations, right? We have a string pattern int rules. I'm just trying to see if there's a way to do this, because walking from left to right, you exhaust your option fairly quickly with this set of constraints. So there should be a way to generate these permutations in a smarter way. Wait, what if I actually pass the regex to the permutations logic here? The issue here is that you don't know if it will pass. But I could actually I could change the regex to allow for the unknown. So if I would change this generate pattern with wildcards, so then I would actually do like this, and this would be a known marker, right? And since this one can be both as well, this can also be unknown marker. So I need to format this, so this needs to be doubled like this. Let's see. So I can do new variant with this, and we can have a regex validation regex if this match new variant, then we proceed, otherwise we exit early. This would actually give us just the valid ones. So this one would be let's see, new variant comma validation regex like this. If we do it like this, we also do else if validation regex of this match input. Actually, we don't need to do this at all because we will validate outside. But this one will only give us the valid permutations now. Okay. So we do regex, wildcard regex is new regex with. We also need to generate that in line, never mind. WR is new regex. And this one becomes puzzle.damage counts. And then we get compiled. This one becomes WR. Let's just make sure that we specify one with and without the regex options here, so that we still have our old version. Okay. So we preserve our old one. Need to strip off this extra stuff that doesn't belong here as well. Like this. Okay. Okay, so we have all of that. I actually wonder if part 1 would be faster if I do it like that. So let me just run part 1 again. See if it first of all spits out the same answer and if it's faster. Did it actually do one already? No. See, you can see that it generates so much data that it doesn't even work. So let's try part 1 again. Okay, it spits out a lot of data. 33, that's not direct answer. That is funny. So my logic there isn't valid. I'm curious to see that. Let me see. What is the validation regex? Let me quick watch. Let's see. So we have any more amount of periods, then we have either a... Yeah, this should be a literal, so I don't need to escape that. Because it's inside of square brackets, so it's not a non-greedy marker. So let's see input. So it should at least still validate this one. Does not match. Okay, that's funny. Ah, because this one actually needs to become like this. Oh, wait, what? So we have any amount of periods or question marks, followed by 2 hashes or question marks. So that could be this one. Followed by 1 period or a question mark. Okay, let's see. No match, wow. Where is it 6 actually? Variance. No, the pattern that's generated here, it says 6, 2, 4, 6, 1. Call stack. Puzzle. Two, 4, 6, 1. Okay, so that's an actual input there. Ah, this one is still... It needs to be either a hash or this one times 6, and this one also, everything needs to be a hash or a question mark. I can never have a literal hash. And now it matches, okay. So I need to update my regex here. The wildcard generator needs to never specify just this. It always needs to have an option with that. So here as well. Okay, let me step through it again. Actually, let's just run the output. 3706, that's not the answer that I had before, so it's still not doing what I want. Oh yeah, that's because I need to have this one also accept a question mark. And this one needs to be a question mark. 8075. Okay, so we're back on track there. So let's not print it now and see if we are actually faster than before. If test, no, actually, yes, let's just write it out if we're testing. No, still not a whole lot faster. Okay, so let's do all permutations. Let's see. Used to be all permutations account. Let's just see if we can, if it actually helps a bit. Let's see. Go to the top. Permutations 2 used to be 4000. That is nice. Okay. So it used to generate 4000 permutations and now it's only 2. But is there any significant time saving here? So it does save a whole bunch of time. 8 instead of 16,000. 13 instead of... So do I dare to run this against a real input? Like this. WR. So let's see if this, let's not run part 1, but run part 2 and see if it actually gives us some woo! Wow, okay. Not what I wanted because it says 0 valid. Jesus. Ah, wait, I run this against puzzle.input, right? No, puzzle.damage. Yes, okay. So this needs to be this. Yes. Phew, got me scared for a second there. Okay. It's not a fast one, but it works. Kinda. Oh man. This is pretty cool. There will probably be one that blows it up, right? I should probably not generate those strings all at once and then validate them, but do it all in one combined thing. I was thinking maybe that I could actually do like a shift. That I first go through everything and then see, like by replacing one of them, if they're valid, and then keep deducing it that way. But yeah. Oh, there was one with like 1 million. I didn't see that. It had how many? 19.5 million valid options there. So it generated 19.5 million strings. Woo! So yeah. And I wonder if there's like a way, if there would be like a factor. So if you take 1, that's 1, and then you add the one with the question mark, and then you have 2, and then you have 3, if that would be enough to extrapolate how it would actually grow. That would be a fun one to see actually. So I think I'll try to do that for some of these. So like the biggest issue right now is generating all the strings, but even then, like checking these many amounts. So let me just save these. Okay, and let's kill it. And let's actually make sure that we do this for 2, because this should be very doable. Okay, now I want all of this data, and then I want to see if there's a way to predict the way that it grows from adding the extra options. So, and I should actually do like const int multiplier is 3. Do this here, and then also add it to the string format here, so that I actually have like this. So I can do Ctrl H, x5, x2, replace everything. Okay, let's not. It's fine. These are x2, and I'm working off screen here. So let me run this again for x3. So this one will be slower. So you can see that at 3 times there is already one that is taking a lot of time, because it generates over 1.5 million entries. So my only hope here is that I have some linear progression, and maybe I can actually use the result from a few days ago, where you just diff the numbers and see if you can spot the pattern. So yeah, at like 3x blowing this up, it's already not a fun challenge for the computer. But I will have enough data to hopefully do some Amarth Day. Sorry for butchering your name, but welcome to the stream. We're doing Advent of Code Day 12. And today is at least the part 2 is a pretty challenging one. Have you done Advent of Code yourself? So basically the idea is you get a pattern where the question marks are either the dot or the hash, and the numbers after it indicate what the hashes should be. And I've wrote some code for part 1 that works just fine. It generates a regex that it then tests itself with the permutation. Got stuck at part 2 as well. Okay. So what I'm now trying to do is take my code that worked for part 1. I've written some for part 2 and blow it up first by 2 and then by 3 times, and then see if I can deduce what adding the copy with the question mark does. So maybe like the advent of code part where you had the steps of increasing numbers. I was like, maybe I can figure out a relation between the numbers so that I don't actually have to do the 4 and 5 times. Because it already generates like, I think I ran the real input and it did 1, where there were like 19.5 million combinations that were valid. So yeah, that is really a pain. So how did you solve your part 1? I'm always curious to hear how people do it. For me, I thought it's like, this is a constraint solver, and I like the basic idea, but I've never done that. So I was like, okay, the only thing that I can think of is have some code that generates the permutations and have a regex that validates it. So that was my approach for part 1. So I have code that generates a regex. Let me just show it while this runs in the background. So I map the input, which is basically just a separated value of the input and a list of numbers. Then I had something that generates a pattern, so any amount of periods, and then specify those, and they are separated by a period. Then for this part 2, to reduce the amount of data that's generated, I generated a pattern that allowed for the wildcards as well, so that even the permutations generator can exit early and save some time there, which is, we already seemed like, okay, instead of 16,500, we generate 2 of them. But even going through that, I assume is just a lot of work. Let me see, I generated all possible permutations for each line and then compared it against the line. Quite brute force actually. Okay. Yeah, mine as well. Still waiting for the X3 one to run. And yes, with part 2, my approach, I almost ran out of memory. Well, that usually isn't a problem for my machine, because I have, and I just rebooted, so I'm not at my usually 60 gigabytes, 70 gigabytes of used memory. I leave open a lot of stuff. So I have plenty of memory to work with. But yeah, even then. Let's see, because at here, right, this one generates 2 million entries. So yeah, I was just saving a notepad. As you can see here, the times 5 times, it grows quite exponentially for some. Not for all, but for some. And I was thinking maybe if I just put them in line and compare them, that I could, if I have data for each of them, that I could individually scale them out. But yeah, I don't have much hope for that. I think if that's not a solution that works, I will have to dive into the Reddit forums and see what the actual solution is, because I'm quite curious to see what the answer would be. So yeah, I should probably do like sheets.google.com and maybe do this off screen, just so that I don't dox anybody or anything. Smap UK, how are you getting along with part 2? I'm not. I have code that works. And I generated it for 2x and 3x, but 5x is just too large of a data set to generate. So even though I have my code that limits the permutations at 5x, even with being smart with generating the permutations, there was like one that did 19.5 million combinations. So it worked for part 2, but it would just take such a long time that I was like, okay, I've done enough optimizations where I can actually run the code for part 2, but it's still very slow. And I think this run for 3x already took 4 or 5 minutes, I think. So it just grows out and out and out. So what I thought I'd do is actually see if I can So this would be 6, 124, 4, 11, 67, 16, 76. Let's see if I just put the other ones beside it here. If there is a way to see how it grows, if there's a way to deduce a pattern from that. Probably not, but it was the only thing that I figured I could still try. So let's see how that works. So this one is 18, 1616, 8, 61, 649, 64, 778. And I have the data. You have to be clever, and I'm not there yet. Yeah. But since I have the data for some, I think I could work some of them out. I might be able to work them out. 15350, 434. Because some patterns overlap, I think not. I don't know. So let's add the X5 here as well. So this becomes 161, 162, 307, 392, 32, 1885, 60953, 1024, 87998, 195, 11227, 5184, 768. Okay. 144, 48, 12, 24. Okay. So which was this one? Okay, so this one actually grows in factors of 2, right? So times 2 times 2, so times 4 actually. So this one is, it grows by 4. So if I would put in the 4x, this one would be 256, I would predict. Right? So it's 1, 2, 3, 4, 5. So the 6th one, I think it would be 256 for the 4th run. Because it seems to scale like that. So this one doubles and this one also. So yeah, it actually does scale like that. If you take the 2nd and the 3rd row, you can extrapolate it like that. I think. Yes, this would be 16 and a 32. Wow, cool. 1616 divided 124. Oh no. Got to go, enjoy the stream. Okay, thank you Sanko Softwares, thanks for stopping by. And hope to see you next time. Snap UK says, I'm trying a new refactor of the unfold to see how much I can deduce extra. Okay. Let's see, I did the wrong one here, right? No. So these is times 18 times 3 is this, times 3 is 162. So yeah, the factor here also works. So this one would be 54. Huh, that is interesting. So 1616 divided by 124, but this one doesn't, which is sad times. 307, 392 divided by 5 is also not a round number. What if I do 307, 392 divided by 1616? It's also not. So for some there's an easy pattern, for others there is not. So what if it's like -1 times 5 or something? So like 60 times 5 is 300. So times 5 is 1500, and then I'm still off here. I don't think I'll be able to get there by doing this. Isn't this actually 11 times? I think I'm close, but I don't actually know. So I can sort of predict the range, and in some cases it scales linearly. 144 divided by 24 is 6. So 144 times 6 is that and that. Yeah. So this one, if they're divisible by each other, they scale. So this would be 864. So that's at least something fun that we notice. If these are divisible, I can extrapolate. Just too bad that it doesn't work like that for all of them. This would be 129 or 192. The only issue is that it's the big ones that I can't predict. The small ones aren't the problem here. So if only I could reason about this better. Is there a way? Because the only thing that I thought of is like I should probably do the first one as well and try to see if I could predict the range based off of that, because you do the difference, right? So let's just run the part 1 as well and just try to see if we, with 3 values, if we can actually make sense of the increasing pattern. I wrote out this one. I need to take out the old permutations count here. This, let's run it. Well, we only need the first few. Let's see, insert to the left, boom. Oh, it generates so much data. Why did it do 2 in one line? That's weird. Okay. Oh, it failed. Wait, what? That's interesting. R is match. That's funny. So for some reason this no longer works. Okay, let's not be too bothered with it for now. So if I just get rid of this right now and just do 2, 10, 2, 2, 7, 4, 8, 13, 4, 3, 11, 6, 4, 3, 1, 1, 3, 2, 3. Okay, I think these are the ones, right? 2, 10. It's weird that it doesn't do a new line here, even though it should. Don't you think this was really weird? Console right line. Oh, did it do a \0 somewhere or something? No. Maybe I'm unintentionally generating something that shouldn't be there. But yeah, it's okay. Actually, let me just do list int counts is new. Counts of add valid permutations. Then I do console.writeLine. Right line. And this can just be string.join, comma, counts. This. Okay. Let's just spit that out for now. And now we have our values, and now I for sure know that I won't actually have an issue there. So if we take this one, the second one, for instance, yes, the second value was 10. Okay, so insert to the left, 10. So the difference between these two, let's just actually do it like column links. So the difference between these is 1, 1, 4. So we can just do is C1 minus A1 is E1 minus C1. Yep. And this one actually is the X5, so we don't have the X4 for that. This one becomes is D1 D2 minus B2. And we are missing data to actually do this properly. Because we only have 1, 2, 3, so I should run 4 for the first two. For day 2, and I'm not running part 2. Okay. Okay. No, left and left. So this one becomes this. So this is G1 is G1 minus E1 is I1 minus G1 is F2 minus D2. Oh, come on. Is H H2 minus F2. Okay. And since this is a factor, it's a multiplier, I don't think this will ever work. But let's see. Is E3 minus C3 is G3 minus E3. And this one then becomes is F4 minus D4. So I don't think this one would stabilize. But if we do it like this, no, let's see, this one becomes is E5. This one becomes, oh come on, is actually F4 plus G5. Is so this will be H4 plus, wait, am I doing this correctly? Oh, this would be minus, right? I'm blanking. Let's see. This one plus this one is this one, right? Yes. So this one would be H4 plus H2. And this one would be I3 is I3 plus I1. Let's see. Now I think I'm spacing here. I need to do something for the wife quickly. Just a second. Send money. Sorry for this. I just quickly need to send my wife some money because she's at the cash register. And tell her that it's done. Okay. Okay. So yeah, I don't think I'm getting here because this then would be is J2 plus I2. So I could actually try and run this with number 6 for the second one and see if that actually works, but I don't think so. But just for fun, let's see. We've done this so far, so we do dot skip 1, take 1. This way we only run this one for input 6, which will be a nightmare probably, but let's see. Because if this one is correct, it should be just over 1 million. But I think the factor grows larger, and I haven't done this one correct. So yeah. See, it grew bigger. So let's see. So if we fill this in right here, then this one becomes is K1 minus I1. This one becomes is J2 minus H2. This one becomes equals I3 minus G3. And then this one becomes equals H4 minus F4. And this one becomes is G5 minus E5. So this just keeps going. But like these differences keep getting smaller. Which I wonder at which point this would stabilize. And is there anything that I can deduce from these numbers? So if I do like is I3 divided by G3, that's a fraction. So is G5 divided by E5 is H4 divided by F4. So even the fraction just keeps changing, and yeah, I'm not sure this will be the way to go. I wish I could, but so for some, to recap, just for some numbers we can actually do this, right? We saw that we could extrapolate for some of them, like if the run from 3 and 2 were divisible by each other, we could just carry that forward and it would work. But when they aren't divisible by each other, we get the numbers that don't work, and I'm not sure that I actually know how to do this. So let's go to reddit.com/adventofcode and see what people have done. Looks easy, only a few combinations, yes. Yep, let's see what people have done, and let's sort by best. Okay, let's see. Joining the array 5 times. Okay, let's see. Dynamic programming in D. Okay, so that's not going to help me. Let's see. This isn't actually the first time I've seen a nonogram Picro solving problem in a coding contest, so it's brought back some memories from 6 years ago. I went straight for dynamic programming since it seemed simpler to me than brute force. I also figured part 2 was going to do something that made brute force too slow. As a result, I didn't have to change my code at all for part 2, besides 5xing the input strings. That made for a very speedy turnaround. Oh wow, he actually got first place on today. So yeah. There are a few things that worked out conveniently. TypeScript allowed out-of-bounds array lookups. Sure. Checking lines smaller than 1 early means checking for whether there's enough room to fit all the runs. In not a few cases go away, blah blah blah. Okay. That's the run length number, okay. Don't quite understand this one, but that's fine. JS doesn't have a convenience memorization helper built in, but it's come up enough in AUC that I just written one myself. Okay, the solution ends up being okay. It's actually much faster. If you're quite careful, you can write the worst case. Okay. So let's see what he did. See if we can understand this. Okay, I don't quite understand this actually. Spot first pick. First spot first pick. Count ways. Okay. But this tries to cache the input here. The thing that I don't understand is why you would get the same input multiple times, unless you check subparts or something. So it keeps taking off 1. Okay, why? If it starts with a period, try to remove it. Otherwise, run left over run this runs. Okay. And I don't follow this yet. So let's try to read somebody else's solution. Picross solve in fact the same thing when generating candidate pattern. The Picross will come fundamentally generate isn't too complex a recursive function, but it definitely took way too long to write this. My primary issue was that the base case, the remaining splits being empty, it was returning instead of yielding. Okay, it was not the twist I was expecting. Still not too bad. Okay. Yeah, I don't see that. When I read this code, it's like I don't see the magic that they're trying to do. So what I think that I'll do is just go through some more code and some write-ups and try to understand the concept that you're actually doing and see how I would introduce the same. Because just looking at that code, I'm not like seeing the trick that they are doing there. So yeah, I'll actually have some other work to do as well, so I'll do that and probably come back to this tonight to try and understand the trick to solving this. Yeah, because I'm curious to see what I could have done to do this better. So yeah, thanks so far for watching, and I hope to see you again tomorrow. Bye bye.